But before we begin our lesson, let's take a look at the objectives. By the end of this lesson, you'll be able to describe change of state of matter and give some examples. Explain what happens to a substance when it undergoes change in state. And explain the term latent heat. Define latent heat of fusion and vaporization. Explain evaporation and its practical applications. We will begin our lesson with change of state. If you heat a solid sufficiently, it will melt and become a liquid. And if you heat the liquid, it will vaporize and become a gas. Energy must be transferred into a substance to change its state in the direction from solid to liquid to gas. Conversely, energy must be extracted from a substance to change its state in the direction from gas to liquid to solid. We use the term phase to describe a specific state of matter, such as solid, liquid, or gas. The compound water exists in the solid phase as ice, in the liquid phase as water, and in the gaseous phase as steam. These forms are also referred to as states of matter. That is, the solid state, the liquid state, and the gaseous state. The transition from one phase to another is called a phase change or a phase transition. For any given pressure, a phase change takes place at a definite temperature, usually accompanied by absorption or emission of heat and a change of volume and density. In the solid phase, molecules are held together by attractive forces or bonds, and this is shown on your screen. In the diagram on your screen, the bonds holding the molecules are so strong that the molecules are not able to move about freely, and as such, they only vibrate about their main position. In the liquid phase, molecules of a substance are relatively free to move, and a liquid assumes the shape of its container. An illustration is shown on your screen. In the diagram on your screen, you will see that the molecules are moving about freely without being held at their mean position. This is because the bonds holding the molecules together are weaker than the bonds that held the molecules in the solid structure. When the molecules have enough energy to become separated by distances, the liquid changes to the gaseous phase or vapor phase. And the figure on your screen illustrates the molecules in the vapor or gaseous phase. In the diagram, you'll see that the molecules are moving further apart than they were moving in the liquid phase. This is because they've gained enough energy, or they've gained more energy than they gained in the liquid phase, and as such, they have more kinetic energy. Therefore, they move more further apart than they were moving in the liquid phase. Adding heat causes increased motion about the molecular equilibrium positions. If enough heat is added to provide sufficient energy to break the molecular bonds, the solid undergoes a phase change and becomes a liquid. The temperature at which this occurs is called the melting point. The temperature at which a liquid becomes a solid is also called the freezing point. In the liquid phase, molecules of a substance are relatively free to move, and a liquid assumes the shape of its container, just like the illustration we saw earlier. When the molecules have enough energy to become separated by distances, the liquid changes to the gaseous phase or vapor phase. When this phase change occurs slowly, it is called evaporation. However, when it occurs rapidly at a particular temperature, it is called boiling, and the temperature at which boiling occurs is known as the boiling point. Some solids, such as dry ice or solid carbon dioxide, air freshness, naphthalene balls or camphor, ammonium chloride, changes directly from solid to the gaseous state. And I believe most of you have seen naphthalene balls or camphor and air freshness in your various homes. This process is called sublimation. A phase change from a gas to solid is also called deposition. Frost, for example, is solidified water vapor deposited directly on grass, car windows, and other objects. These changes have been illustrated in the diagram on your screen. In the diagram on your screen, when solid melts, it forms liquid in the process called fusion, and the liquid in turn evaporates to form gas, also in a process called evaporation or vaporization. And when the gas condenses to liquid, it is also called condensation. And when the liquid freezes back to solid, it is called solidification. Now, when the solid changes directly to gas, the process is called sublimation. And when the gas in turn changes directly to solid, the process here is also called deposition. I hope you understand the diagram clearly. Very good. Let's continue. Let us now turn our attention to latent heat. What is latent heat? An iceberg can survive many weeks floating on the sea before it all finally melts. It takes much longer to turn a kettle full of boiling water into steam than it does to bring cold water to boil in a kettle. These examples show that a lot of heat energy is needed to change ice into water and water into steam. This heat energy, which changes the state of a substance, is what is called latent heat. Latent heat means hidden heat. The heat which changes ice into water is hidden in the sense that when the ice melts, it is no longer hotter than before it received the heat. Latent heat turns ice at 0 degrees Celsius into water also at 0 degrees Celsius. So latent heat changes the state of an object without causing any rise in temperature. I hope you are taking note of that. Latent heat is the amount of heat needed to change any mass of a substance from one state to another without change in temperature. When a solid changes into liquid or vice versa, the heat absorbed or given out is called latent heat of fusion, like we saw in the diagram. A solid will melt when latent heat of fusion is applied to it, and when latent heat of fusion is removed from a liquid, it will freeze. When a liquid changes into gas or vapor or vice versa, the heat absorbed or given out is called latent heat of vaporization. Latent heat of vaporization given to a liquid evaporates it. Latent heat of vaporization removed from a vapor or gas condenses it, as we saw in the diagram. Latent heat does appear as increase in heat content of the steam. Therefore, the vapor of a liquid at its boiling point has more heat than boiling liquid. Let us now take a look at an experiment to demonstrate the change of phase. In the diagram on your screen, solid or ice at -5 degrees is heated and it will start melting at that point. And at this point, there's no change in temperature, as you can see on your screen. When it melts, that's when the ice melts and it turns to water and is heated again, there is a rise in temperature. When the liquid or water begins to boil, the temperature remains constant. Now, when all the liquid turns to gas or steam and is heated again, the temperature rises again, as you can see on your screen. The topic under discussion is still latent heat. And at this point, I want us to turn our attention to evaporation. The particles of all liquids and solids have an average kinetic energy that depends on temperature of the liquid or solid. However, because of the random collisions and vibratory motion, some particles have energies higher than average and others have energies lower than average. When the particles on the surface of the liquid or solid acquires enough energy to overcome the forces that holds it as part of the substance, the particle escapes and becomes a particle in the vapor phase. I hope you understand me clearly. When vaporization occurs from liquid, it is known as evaporation. And when vaporization occurs from solids, it is known as sublimation. Sublimation is a direct change from solid to vapor without passing through the liquid phase. And an example of this is the naphthalene balls or the camphor you normally use in your various homes. You realize that the size of the camphors keep on reducing day in, day out, meaning it is subliming. it is changing gradually into the gaseous phase. Evaporation is the change of phase from a liquid to gas or vapor. The energy of the particles that evaporate from a liquid is obtained from the surrounding atmosphere or from the remaining liquid. Evaporation therefore produces a cooling effect. Let's see some examples of evaporation. When rubbing alcohol is applied to the skin, it quickly evaporates, producing a cooling effect. The cooling effect is greater because alcohol evaporates more rapidly than water. When ether is placed in a shallow dish, within a short time, the quantity of liquid decreases and the odor of the ether becomes quite strong near the dish. The molecules of ether evaporate into vapor and mix with molecules of the gases in the surrounding air. Evaporation depends on the temperature and the surface area of the liquid exposed to the atmosphere. Evaporation of water from an open container becomes evident only after a relatively long period of time. Let's now take a look at evaporation and perspiration. Although evaporation is a slow process, it is often important in preventing our bodies from overheating. Usually, radiation and conduction are sufficient to maintain a rate of heat loss that keeps us comfortable, given the temperature difference between our bodies and our surroundings. However, when the air gets hot and the temperature difference narrows, we start to perspire. The evaporation of perspiration helps cool our bodies. On a hot day, a person may stand in front of a fan and remark how cool the blowing air feels. But the fan is merely blowing hot air from one place to another. The air feels cool because its flow promotes evaporation, which removes heat energy. This is why sweating cools you down. Let's now take a look at evaporation and drying. Damp clothes on a washing line dry because water from the cloth evaporates. Similarly, a hair dryer causes wet hair to dry due to evaporation. Let's also take a look at evaporation and salt. Salt is extracted from the seawater by allowing the water to evaporate over a long period of time. Evaporation is also used to dispose of brine from desalination plants. And you know what brine is? Salt solution. Mines also use ponds to separate ore from water. Let us take a look at water in a clay pot. Some water from a porous pot comes to the surface of the pot. Water on the surface of the pot evaporates, taking heat from water in the pot. The heat loss causes the remainder of the water in the pot to cool. How time flies. All too soon, we've come to the end of another lesson. Let us summarize all that we've learned in the lesson. In this lesson, we learned about latent heat and evaporation and their practical uses. We also learned about change of state and gave some examples. We explained what happens to a solid when there is change of state. We also explained what is latent heat. We also defined latent heat of fusion and vaporization. We demonstrated an experiment to show the change of state. We explained evaporation and its practical uses. I hope you have enjoyed this lesson and you've been educated. Until we meet again in our next lesson, keep on practicing and solve more questions on the lesson to help you understand the lesson better. Thanks for having me and enjoy the rest of your day.